All right, let's get started with the keynote speaker.
Yeah, our keynote speaker is Ankur Kotwal, who leads Google Cloud Global Advocacy team, acting as a bridge between platform and the developers who use it. With a career journey that's taken him from software engineer to product architect to developer advocate, Ankur is passionate about simplifying complexity and accelerating innovation through AI. Through AI seamless developer experiences and powerful tooling. Please give a warm welcome to Ankur Kotwal, presenting Agentic AI Revolution. Thank you.
Good morning, everybody. Hey, yes, let me unlock my laptop, the moment of truth. And I will make sure that my tethering is working before we get started, which it's, of course, not. There we go. And all right, here we are. My name is Ankur Kotwal, and it is a real privilege to be back here in DevFest Sydney. Thank you all for coming. I've been at Google Sydney for 14 years now. I've been in developer relations the whole time, and I lead a team called Global Advocacy. We have an amazing set of DevRel engineers all over the world that are there to listen to your feedback, that are there to share information with you, share our best practices, bring products to market, and work with our product and engineering teams to do so. So I'm thrilled to be back at DevFest Sydney, but I'm even more excited to be talking to you today about agents, AI agents. Now, I'm sure you've heard those terms thrown around quite a lot, building AI apps, but agents are different to standard apps. If you think about the way we've been building software or the way software has been designed for many decades now, we tend to have a set of algorithms, some sort of input that goes into them, and some sort of output that's generated. We're designing the whole sort of control and flow of those apps, but when it comes to agents, I don't know why it's flicking. If that stays as an issue, we'll put up with it. But even though we've had this sort of traditional way of building apps, agents change the game. They really are a different way to think about the types of software that you can build and how you build that software as well. So let me define what an agent is. We think of an agent, an AI agent in particular, as something that uses LLM models and are able to act independently. Now, I don't want to read word for word here, but these words are really, really important because an agent is given a goal and it goes and acts independently to go and solve that goal. It knows when it's done, and so it's very different to traditional software where you are not necessarily setting a goal, but you're giving it a series of steps in sequence to go and achieve that goal. With AI agents, it's very, very different. So I'm going to switch to a demo. Apologies for the screen flickering. I think it's just going to come and go, but rest assured, we should be good. And let me bring my cursor here. All right, so how many of you have used Gemini Deep Research? Good, a fair few of you. So I had a problem recently where, well, it wasn't a problem. I received an email from my electricity provider. This is a true story, right? Said my rates were going up. And now I've been with this electricity provider for a number of years, and I was like, this is a good time to go scour the market. A lot of people use deep research for studying or deep diving on a particular topic. What I thought is I'll use deep research to go and find me the best electricity plans. And so I don't actually live in Surrey Hills, but that's what I'm going to use as an example today. So I've said here, we'll let the flicker happen. What I've said here is go and find me the best electricity plans. I also have solar panels, so I care about the rate of when I sell electricity back to the grid. I have gas heating, so I want to look at gas rates. And I've even told it that you can consider whether I get better discounts if I bundle my electricity and gas together, or use two separate providers. Go ahead and find that for me. Now, Gemini Deep Research is an agentic app. So I gave it a goal. I told it to go and solve this for me. And what it's done is it's put together a plan. We can go through the details. I'm not actually going to change the plan, but it's basically expanded what I told it to do and given me a plan for it. And then I'm going to say go and start research. Now, the great thing about Gemini Deep Research is that it can take up to 10 minutes. Now, you might think, well, that's annoying. Actually, I find that to be great because it's very exhaustive. And we're not going to spend the first 10 minutes of this keynote watching this spinner go round and round. I do want to show you what it does. And what it's doing right now is taking that plan that it said it would enact, and it's going and starting and doing a set of Google searches and going and fetching some initial information. And then based on that information that it gets back, it's going to go do even more scouring of the web. And so I'm hoping that in a few seconds what we'll see here is this starting research will move on to searching websites. If it doesn't happen in a few seconds, we can come back to this. So that's not a big issue. So I'm going to come back to this in a minute. The reason I wanted to show you that demo, even though it wasn't particularly awesome yet, is that is an example of an agentic app. This deep research isn't specifically designed for electricity plans, but I'm using it in that capacity. So we've now defined what an agent is. Let me show you what an agent needs to be successful. And the first is the actual LLM itself. Now, you can use a mix of LLMs. You don't have to use just one LLM for all the processing that you do. But you also have to realize that LLMs are trained with a finite and fixed set of data at a particular point in time. So the Gemini 2.5 models, their knowledge cutoff is January 2025. So everything that's happened in the world since January, it's not aware of. And now when I look at energy prices, that matters. I want something current. So what you can do for your agent is actually augment that model with tools so that it can start to get more contextual information. That could be real-time information. It could be information about your users. And we're going to see some examples shortly as well. So before I talk about building agents, let's just see how our demo is going. It's still saying starting, but I don't actually believe it. So I'm just going to hit refresh. The nice thing about deep research is it sort of keeps going. Again, apologies for the flicker. I'm not sure why it's doing that. And this isn't going to actually recreate the whole task. What it's going to do is just catch up to where it was up to. So you can see here, hopefully, it was saying it was reading 122 websites. And initially, it would have started with about 20, grown to about 50. And you can see now that it's going and building out this plan that I asked it to. So it's checking all these different sites that it's found. That's an example of an agentic application. So we've seen how Gemini Deep Research does it. Let's talk about how we can build these ourselves. Google has a framework called the Agent Development Kit. And ADK is an open source framework. And actually, just today, we released the 16th iteration of it, the 16th version. That's huge because we only launched it in April this year. So you can see the pace of change. Sundar talked about warp speed, pace of change in the industry. This is an example of it. It is entirely open source, so we do accept PRs from folks as well. And the cool thing about ADK is it's not just about building a single agent. It supports all sorts of different patterns. The other really nice thing about ADK is that it's got a local developer UI. So this thing that you see on the right-hand side is actually a trace of the user interacting with the agent and you starting to see how things flow through. And I'll show you a little bit of that in a minute. Now, ADK is entirely open source. Out of the box, it has support for Gemini 2.5. Oh, actually, it starts with Gemini 2.5 Flash, and I'll show you that in a demo. But you can use any model that you want. It's not hard-coded to using Gemini. So it makes it super powerful that you can build your agents and then choose the right model that fits your needs. Now, we can call lots of different tools, and not just local tools that we provide, but also remote tools using something called MCP, and I'll talk about that in a minute as well. Now, ADK is available for Python and Java today. We've got more language support coming. JavaScript is coming quite soon, actually. So let's switch to another demo. I've got to come back here, and I'm going to switch to my terminal. I'll just clear that. Can you all see that okay? All right, so there's nothing in this directory right now. There's one hidden file, and I'll show you. What I'm going to do is create a simple agent with a single command, ADK create simple agent. It's going to say which model do you want to use. I'm going to say go ahead and use Gemini 2.5 Flash. It's going to say give me your API key. I'm going to give it some rubbish, but I told you there's a secret file here. I'm just copying my API key across. That's it. It's gone and created a basic agent for me. And if I say ADK web, trust me, that's what I typed. We will switch to the browser. I said ADK web up the top there. You'll see it's spawned off a local server. So I'm just going to go ahead and control-click that. You see here what looks like a chat UI. And so this is a very basic agent. I can say something like, hello. It'll call Gemini 2.5 Flash. This is not very terribly exciting. In fact, let me show you a limitation. I'm going to say, what's the weather in San Francisco tomorrow? And you'll see that it's actually going to give me a fairly naive response back. I apologize if you can't see that. Actually, in that case, I'll just try it one more time. In San Francisco tomorrow. Basically, what I'm just trying to demonstrate here, hopefully the demo gods are with me, the projector gods are not, is that it will tell you that, hey, I don't know about the weather in San Francisco tomorrow. It says, tell me today's date so I can determine tomorrow, right? So it's really not that intelligent yet. So how can we make this more intelligent? Let's talk about that. It's tools. We have the model, but all we're doing is talking to this thing that has a lot of information about the world and code and so on, but nothing real time. So a tool is a way for us to expand the capabilities of our agent. We're able to give those capabilities to the model so that we can go and add that additional context. And the way that it all works is that the agent actually calls the model, and it tells the model, these are the tools that I have available to me. And then the model decides which tools to call, and it does that routing through the agent. And then it's able to go ahead and do these things. So we're going to look at an example in a second, once the flashing is done. So we're going to use the Gemini model. We're going to have an ADK agent that we're going to build, and I'm going to show you different types of tools. Now, the first type of tool is called a function tool. Now, you've got your own code existing in your applications. ADK isn't just about building greenfield or brand new applications. You can start to add agents to standard, like your existing software too. So you'll have functions, you'll have libraries that you want to call. What you can do is wrap those functions in this function tool, and then ADK is able to call it. The next one are built-in tools. The most popular one that we see is that we have a Google search tool that comes with ADK. Now, I'm not going to go into tons of detail about these things because there's a talk right after this one on ADK that Lovey is giving. So please stay in the room for that one. So that's the built-in tool. But we also support third-party tools. Voila. There we go. And with third-party tools, you can add other frameworks in as well. And so I'm going to show you an example. Even though I'm showing here that there's like Stack Overflow and GitHub, I'm going to show you an example with Wikipedia. So let's switch to another demo. All right, I'm going to first stop this guy because it's going to run on the same port. I'm going to switch to my VS Code instance. Start this guy up. Now, in this one, we have two agents here. I'm not going to talk about the energy prices one just yet, but I've got this thing called a personal agent. Let's go back to opening up this, and let's select, because I've got two agents, we're going to select our personal agent. Let me make that a bit bigger for you all. Now, the interesting thing with this is I've equipped this agent with some tools. So this time when I say, what's the weather in San Francisco tomorrow, the first thing you'll see is that it's going to look up the Google search engine agent. So that lightning symbol means it's calling an agent. It's gotten a reply, and what you'll see here is straight away we've got the weather. But I also added another tool for it, this function tool, to go and do currency conversion. So I can say, what is 100 USD in AUD? And you'll see now it'll call this get FX rate, and it will tell me the real-time price of the USD to AUD conversion. Now, we had some really cool news earlier this week. A few Googlers got recognized as part of the Nobel Prizes for their work in quantum computing. Now, that happened just a couple of days ago. So obviously, the Gemini model wasn't trained with that information. I've also added the Wikipedia agent here. So we're going to say, which Googlers were recently awarded the Nobel Prize? Now here, it's actually going to call Google search first and pull up this information. There should be 5 names, but this is an LLM, and a live demo, so we'll see what it brings. And you'll see here in 2025, Michael Deverett and John Martinis were recognized for their work in quantum computing. That's cool. We can see that those Google search results coming. Let's say, what's the history of the Nobel Prize? And now you'll see it's calling a Wikipedia tool. I'm going to show you now how much code goes into making all of this work. Hopefully you'll be more impressed than this black screen. But the point I'm trying to make is that we've called Wikipedia actually here and pulled down the history of this Nobel Prize. So switching back to our code, and let me just minimize this because you won't see it otherwise. Okay, so in our agent, ignore the imports for now. This is the whole code for our root agent, the entry point. We say we're using the, unfortunately my clicker is interfering with VS Code. We say we're using a model, the Gemini 2.5 Flash model. It's the root agent. We've given it some instructions as to what it does, but we've actually equipped it with 3 tools. We've said we've got one for currency conversion, a Google search agent, and we're using LangChain's Wikipedia tool. So let's have a look at that custom function, which is the FX rate. Actually, let me just see if... I'm going to zoom out one level so you can just see that a little bit more. And you can see our FX conversion rate. There's very little code here. In fact, ADK, sorry, my laser pointer is triggering that. ADK is actually using those doc strings where it describes what this function is and describes what those arguments are, and it's working out when to call that. If you looked at that agent code, all I said was function tool, and I wrapped it with this function. The rest of it inferred from here. If we look at the third-party tool where we're using Wikipedia, there's even less code. We're using LangChain here. LangChain provides some Wikipedia imports, and I've just said wrap that in this third-party tool. So with that, we were able to provide so much more capabilities to our model. We will switch back to the first tab, once I can see it. Oops, that's not the tab. Oh, this is our report, sorry. I will come back to our report in a minute. So, I talked about MCP. Now, MCP is actually a protocol that was published by Anthropic late last year, around November, and it really started to get adoption earlier this year. And what MCP does is it makes it very easy for AI models to go and talk to tools. So you'll see across the industry this year, all the big players and even the small players have started to adopt MCP as the protocol for AI applications. And so if you think about building a traditional application, let's say you're talking to a Postgres server, you're talking to Stack Overflow and GitHub, each of these services have their own APIs. So when you have to go and build for these applications, you have to build bespoke integrations against each of those APIs. Now what you can do is actually publish an MCP server that wraps that API. So the vendor would do that. And then you can consume those MCP servers in your applications without knowing what is the underlying mechanism for that API. So MCP, you have a client that sits in your AI agent. And again, ADK makes it super easy to consume MCP clients or MCP servers. It's got a client built in. And then all these vendors publish MCP servers here, and you can just have this like open protocol, a bit like the web, where it doesn't matter which platform you're on, you're able to go and consume different web pages. MCP does that for APIs and backend protocols. Now I want to switch back to our electricity prices demo. So let me come back here. Now I'm going to go back to that Gemini deep research. And what you'll see is that you'll see in a minute, what it's done is generated a very exhaustive report of electricity prices. So you'll see on the right-hand side, there's a scroll bar. This thing goes on and on. It's telling us what the different ways that you can get billed are between daily supply charges, usage charges, the feed-in tariffs, so on and so forth. What you'll see further down is a price comparison table. And as a user that is looking for better energy rates, this is the kind of information that I was after. So it's automatically gone and scoured the internet and sort of given me the different rates. It even tells you what special conditions they have, because these plans are typically not apples to apples comparisons. And so you can see deep research in this agentic experience that it's provided me. It's given me a lot of information for me to parse. And then towards the end, it even makes me some final recommendations because I asked for it. Now imagine we were trying to build that with, with our ADK application. You might think that, oh, this is like super difficult to go ahead and do. What I'm going to first do is actually just switch to that, agent there. So we were using the personal assistant. Let's switch to energy prices. And what I'm going to do, I'll just copy and paste this prompt. Where are we? There. So I'm going to give it a much more, oops, clearly not what I copied. I'm going to give it a much more simple prompt. What's the best energy plan for Surrey Hills? I'm looking for electricity, solar feeds, so selling back to the grid, and gas. And now it's going to go ahead and look online, use the Google search tool. It's going to go pull in that information. Now, whilst it does that, let me show you. It's going to black out just as I go to show you. Yep, right on cue. Let me go and show you what the code looks like just while it's doing its thing. So if I look at this energy prices thing, there's just one agent file in there. That's all of the code. So I've just described it to say, hey, oh, again, sorry, apologies for that. It says go and use Google search to find and compare electricity, solar feed-in, blah, 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 for the user's location. I told it Surrey Hills, so it should match that to a postcode and do the search. And I said for each provider that you found, go and find the plans that they offer. That is all of my code, and you'll see the result that we get is right here. I'm just going to scroll up in my ADK app here. So you'll see that it says, hey, to determine the best plan, you need to consider these things. It goes and tells me what regular costs are, giving me very specific quotable numbers as well. For gas, it even tells me what gas providers, because with gas, for example, there's certain providers in certain regions. It can tell you which providers cover that particular region. And it tells you, how do you find the best plan for you, and so on and so forth. So whilst it's not the full experience of the Gemini Deep Research app, it's actually quite a lot in just a few lines of code. And that's what I want you to take away from this, that agentic applications, they really change the way you think about the kind of software that you're building and how autonomous they are. We just gave it a goal to go and help the user find the best prices. It did the rest. And the only tool that I gave it in that case was the Google search tool. I could have taken it even further and added a comparator tool and things like that. But that's, Logan, again, in the kickoff, said that you can go to an app in 90 seconds. This was a little bit more than 90 seconds, but probably less than 3 minutes, right? So super, super easy and exciting to do this. Now, it turns out that building agents, there isn't just one way to do it. we're starting to see an evolution of different types of patterns that people are using to build agents. So here is a single agent pattern. Now, in this case, the use case here is we're building a customer support agent. Nobody likes waiting on a phone for customer support or even waiting in chat rooms for customer support when all you want to do is refund a particular product that you've bought. So step one, what we're going to do is check that the user actually purchased that product. We're going to check their purchase history. Step two, we're going to check if that particular purchase is eligible for refunds. If they've bought that product 2.5 years ago and are trying to refund it now, it's probably ineligible. So there's certain categories of eligibility, and then step three would be processing the refund. Now, in this case, we would have a single agent, and those 3 blue boxes that I just talked about, they're the tools that we would have equipped it with. That single agent can encompass all of that, and we're using Gemini 2.5 Flash. That's a very simple way to solve this problem. Let me go to the other extreme. This one has a lot more arrows on it. This is called the coordinator platform, a coordinator pattern. Now, in this case, we actually have a parent agent, this tall yellow box here, and it's got some sub-agents that go and do, again, the purchase verification, the eligibility, and the actual refund processing. But in this case, I think it's too complicated because we have this parent agent that's coordinating which way everything should go. We're going to be doing a fair amount of prompt engineering so that we're guiding it in the right way, and it's going to decide when it needs to call each of these things. And each of these agents has their own tool that maps one-to-one. But in general, you're really, in this pattern here, you're really leaving it up to the model to decide everything. I think for this particular example, this is too complicated. But this is a valid pattern for different styles of applications that you may be building. So let's take it simpler than this. Now, in this case, we're going to use a sequential workflow. So we still have a tall kind of parent agent and some sub-agents, but you'll notice it goes top-down here. We're actually going in order of verifying the purchase, checking refund eligibility, and then going ahead and doing the refund itself. But if you look at this, you can start to realize that there's an optimization that we can make here. Because every time you call these LLMs, it requires some processing time. So we could probably speed this up with a parallel workflow. We can actually check whether the user actually purchased that application at the same time that we check what the eligibility criteria for that particular product is. So now, instead of having 3 sequential steps, 2 of those steps can happen in parallel, and then we can go and check the refund. We can go and then process the refund itself. And finally, the 5th pattern is one where we can show a custom flow. So now you can mix and match different patterns. And what's cool about this one is this little diamond here. So the top part is the same. We're going to kick off our chat. We're going to verify the purchase and the eligibility. And then we can have basically like a decision tree, like more traditional software, where we can say, depending on if they're eligible, we can go and do different things for them, whether it's offer them some store credits or discounts, or actually go ahead and process the refund. And so now you get to start to see you can mix and match these things to give your users a delightful experience. So the takeaway on the patterns is there are lots of ways to do this, and these patterns are emerging. These are the ones that I've shown you are some of the most common patterns that we do tend to see, but you get to mix and match these as in terms of what makes sense for you. My big piece of advice as you go to start using and playing with agents is start simple. Only add the complexity, and this is just good software engineering advice. It's not specific to agents, but start with the most simple way that you can do things, and then start to add some of that complexity. Especially then you start to see optimizations for doing things in parallel and so on, so you can improve latency with your applications. Now, even though I'm telling you how excited I am with agents and hopefully wowing you with some of these flashing demos that go black and white all the time, this doesn't mean that you should use agents for everything. There are times when agents will work really well. Agents allow you to build really flexible software where the parameters of what your users need could go in any direction. Now, Gemini Deep Research was an example of that. Again, it wasn't built for finding good energy prices, but it helps. The cool thing about using ADK to build your agents is that you can prototype very quickly. Within seconds, you can get started. It doesn't require a lot of code, and then you can start to do things in an interesting way. Now, with that energy provider example, I just showed you a one-shot, like kind of one-off, go find me the best prices. But actually, we could have made that far more useful for our users by being proactive. So imagine your users actually create an account, they kind of put in some information about what plans they're on now, and we could send them a weekly or a monthly update that says that you are still on the best plan right now. These prices change all the time. And that's a very common example. I don't think it's a billion-dollar idea, but people change ISPs, they change mobile phone providers, electricity. There's a whole category of things, just general subscriptions that people tend to have as well. So you could imagine a proactive version of this, which truly would be an agentic application. But you also got to realize that there's trade-offs that come with these agents as well. I showed you some ways that there's patterns, agentic patterns, that can kind of become hard to follow. You want to make sure that you have a very easy to understand sequence of steps. I didn't actually show you the local dev UI much in ADK. I hope Lovey will be covering some of that for you as well with the traces. I showed you an animation, but I didn't do a live demo of that. So that predictability becomes really, really important. You want the same results every time, not something random. Now, the other thing is, I told you how fast-paced this industry is right now. And so you want to pick a framework. I think you should use ADK, but there's lots of other frameworks that you can use. You want to pick a framework that's stable as well, because you do see that in this fast-moving world, API stability isn't always there, and so you might upgrade from one version to a next, and suddenly your code isn't working. ADK really is meant for production-ready applications. And finally, you want to make sure that you have observability built in. Again, ADK provides this. It provides traces and logs and has support for open telemetry, so you can view it on your cloud provider, and Google Cloud has got great integrations with all of that. But you want to make sure that as you're operating your agents at scale, that they are behaving the way you expect them to. Now, in terms of overcoming these challenges, what you want to do is make sure that whatever models you use are reasoning or thinking models. In all of the examples we looked at today, we used Gemini 2.5 Flash, but I had quite a few different agents that I showed you today, right? I could have used a different model for each of those agents. Now, when you're looking at picking a model, you're really looking at trade-offs across three things. One is the quality of the response. How capable is that model? The second is its performance or latency. How quickly does it get you an answer back? And the third, really important, is cost. Because if you're running these agents and they're kind of iterating and going in loops themselves for a number of iterations, that cost can add up. So you want to have the right trade-off between capability of the model, latency of the model, and cost. But make sure that you're at least picking models that are reasoning or thinking models, like the Gemini 2.5 Pro and Flash models. You want to make sure that the LLM that you're using is grounded with the right user context and data, so that it's not going to hallucinate and make up results. That's why we were giving it the Google search tool and the Wikipedia tool and so on. Something I didn't cover is state management and memory. So when we have that chat, and by the way, not everything needs to be a chatbot. I just demonstrated with a chatbot. You can have a beautiful UI in front of all of this. But you want to make sure the history of all of that conversation is taken into context when it's giving responses, that each of those messages don't just seem like disconnected to everything else. Now, ADK provides that out of the box for you. What you want to do is make sure that you save that, serialize it, and then pull it back when the user logs in again, perhaps on a different device. So state management and memory become really important. And this is, again, just general great software engineering practice. Make sure that you build really good evaluation frameworks for your agents and test them thoroughly. You are going to change models. You are going to change frameworks. You are going to change your prompts and the tools that you use. And so you want to make sure that you have a really robust set of evals set up so that you can move forward. So I hope you're as excited about agents as I am. this is really opening up a huge range of possibilities for us all. And I'm thrilled to be able to talk to you about it. So thank you very much for joining me today. I'll take up questions now.
All right, if you have any questions, just raise your hand. Our team will hand the mic to you.
We've got one here at the front.
Hi, my name is Biswa, and first of all, fantastic presentation on ADK, and it's very knowledgeable. I'm very excited to work with the ADK. And so my question is, recently, OpenAI has shown in one of the developer conference how they are making the agent development by a drag and drop,
yes.
Right? So does Google have similar, like not similar, but I saw Opal, one of the project in which you can prompt it and make the workflow. Does Google have now anything come with making some agent orchestration by drag and drop, something like that, on a based on ADK in the back end, but in a simple drag and drop in the front end for everyone to start developing the agents?
Yeah, great question. So to paraphrase that question, I'll say that there is a lot of great tooling that's coming out from many different providers. So OpenAI had their one, I think it's called Agentic.
Agent Builder.
Or Agent Builder is part of Agentic. There's a company, there's a tool called N8N that does something similar as well. What you're seeing is a lot of, like, the pace of change is really fast, and so you are seeing these kinds of tools come out that make it a lot more visual and drag and droppy and that sort of thing. Google has some of that, and we've got more coming that I can't talk about. But what I also want to just preface is they are designed for different types of users. So when you have a pure visual drag and drop interface, right, you kind of cede a lot of control from it. So one of the reviews that I saw about, or initial feedback that I saw about OpenAI's Agent Builder was that they kind of hide the complexity, which is good, but then you end up with lots of boxes that you have to click around, and any level of complexity that you've got in your agent, it's not as easy to change. So, and again, they may add more capability to this, but people were asking, could I go back and forth between my visual designer and the code? And today you can't, right? And so yes, Google has things like Opal, things like Stitch. They're not specifically for agents, but they allow you to design software as a whole. And so you can kind of abstract that agentic piece. But there's going to be more coming, which obviously I won't go into. This is a really fast-moving place. Oh, sorry. I'll go ahead. Go ahead.
Hi, my name is Wu. As I'm deep dive to Gemini and ADK for a while, and my question is, when it comes to productions enterprise level programming language, Java, Python, which is your recommendation?
Actually, that question, to answer that question, so the question is for production-ready agents, should I choose Java or Python? It really depends on your workplace. Like, both languages are production-ready, and ADK supports that to a production-ready level. The thing is, what are your skill sets in your organization?
Java.
If you're a Java shop, stick to Java, absolutely, right?
So how about type?
Sorry?
Yeah, types in Python or Java. So when it comes to Python, we have it Pydantic. So I don't love it. So I think Java is stronger in that sense.
And so we do have ADK Java for that very reason.
Yes, that's
right?
why
That's what I'm saying. So in general, when you go to approach this technology, think about what are your skill sets. If you're having to learn a whole new programming language and tool set, that's a big lift. You may not have the environment to deploy that in production as well. So you do need to consider that. And so we do continue to take feedback on that. Right now, the Python ADK is the most furthest along in terms of features. The Java version is not that far behind. And as I said, we've got JavaScript, and there's other languages to come as well.
Okay, thank you. And the second question is how should we design the workflow? I mean, the pipeline. I see lots of function calls on the screen. So,
as I said, start basic. Start in the most simple way you can. You can probably do it in a single prompt, and then think about how you might want to add modularity to it. So there might be, if you saw in the demo that I gave, I had 2 agents. I had this personal assistant that did the Nobel Peace Prize and foreign exchange rate and so on. And then I had a different agent for the electricity prices because I didn't think that they needed to be connected in any way. That was a good line of separation. So again, traditional software engineering practices, think about what things belong together, couple those, and then sort of have modules for the rest. And so you can split them out as sub-agents or even entirely independent agents as well. It really just, there's no one answer that answers it all. We've got the options there.
Yes, for example, we have already have a case from the customer. And yes, we have a starting point and we have existing solutions without AI, ADK, anything. And we want to apply the model, some function code to the existing pipeline. So what is your recommendation?
I would, again, start with like a function tool or something and wrap that and make it available as a tool to that particular agent and go from there.
Yeah, thank you.
Yeah.
We'll give that as the last question.
I think this might be the last one in terms of timing.
Hey there. You mentioned at the end that testing the agents is very important.
Yes.
I'd agree. Given that their sort of outputs or their reactions aren't really deterministic, how do you go about testing them?
Yeah, so this comes back to just generally like how do you build robust evals for AI apps? So that might be just using a single model or building out agents. Again, this is a rapidly moving field. ADK has, it's now switched, but actually there was an eval tab in the ADK Dev UI. So you can actually run a set of evals, snapshot them, make some changes, and run another set of evals. The prompts that I gave were very broad, to be very honest with you. So you might want to give some anti-prompts, like the electricity provider thing. You might want to say, don't answer any questions other than for electricity providers, right? So you can, again, narrow the problem space so that your model is only taking on those particular tasks, and then run evals, change up, use different models, use different frameworks or versions of frameworks, and then see how you go against those evals. Google Cloud also provides a whole set of eval products. So we actually have to deploy agents on Google Cloud. Cloud Run is the simplest place to deploy agents, to be very honest with you, ADK agents. We also have another product called Agent Engine, which actually builds on top of Cloud Run. It uses Cloud Run under the hood, and it has an evaluation service built in as well, so for production-ready kind of applications. So there are options out there, and it's evolving very quickly. Thank you. I hope you have a wonderful DevFest today.